Hi students, myself Jagadish GM, Department of Physics, Kotureshwara College, Kotur. Today I am going to demonstrate one of the important experiment of the BSc 4th semester, interference of a wedge or air wedge. So here, to determine the thickness of a given paper by the method of interference at a air wedge. So see here, so what is the air wedge is nothing but, so in between the two glass slides or glass plates, thin glass plates, for example, so this is one of the glass plate, and you take the another glass plate. So here you take one of piece of the paper. In between two glass plate, a piece of paper is sandwiched at one edge of the glass plate. So it is nothing but so it creates a thin air film in between the two glass edges. So this air film is nothing but a air wedge or a wedge. Okay. So see here, so using this air wedge, you have to measure the thickness of a given paper or a thin paper. So by the method of interference. Already you are studied what is interference means. It is a superposition of two light waves or light rays. So nothing but using that phenomena, interference, we have to determine the thickness of the given paper. So see here, when the interference phenomena occur, we have to observe a alternative dark and bright fringes. So this is nothing but a fringe pattern we have to observe after the interference of two light rays or light waves. Okay, so using the microscope, so we have to check or we have to observe these fringe pattern. So alternative dark and bright fringes occur. Okay, yes. So see here, what are the observations? First, we have to note down the least count of the microscope. So it is LC is equal to value of one main scale division divided by number of Vernier scale divisions. So here, 1 MST, value of 1 MST is 0.05 into 10 raised to minus 2 meter divided by 50 divisions. Okay. So we get 0.001 into 10 raised to minus 2 meter. So this is the least count of the microscope. Then wavelength of the sodium light. So here we have to use a light source. It is nothing but a sodium light. So we have to use the sodium vapor lamp source. So nothing but here we have to take the wavelength of the sodium light. Lambda is equal to 5.89 into 10 raised to minus 7 meter. This is given already given data in your exam section. Okay. Yes. So next is length of the air wedge. L is equal to 7.8 into 10 raised to minus 2 meter. So it is nothing but it is the length of the air wedge. So here to here. So already I told that we take the two glass plates, and in between the two glass plates a small piece of paper is sandwiched. So that is nothing but a air wedge. Here we have to take the length of the air wedge. L is equal to 7.8 into 10 raised to minus 2 meter. Then what is the formula used? Thickness of the given paper, T is equal to lambda L by 2 beta. Okay, yes. When you observe the fringe pattern using the microscope, first you have to note down the least count of the microscope. After that, so see here, so this is the tabular column of the experiment. So microscope reading. So here you are already know the how to take the value or measurement in the microscope. So we have to observe MS or CVD and calculate the TR. So see here, for example, order of the fringe is so 0, 5, 10, 15, 20, 25 like that. Okay, so up to we have to using the order of fringe up to 55. Okay, and also so corresponding MSR CVD and calculate the TR. Okay, yes, for example order of the fringe is 0, so we have to check or take the value MSR CVD. Okay, so for example you have to move the order of fringe 30 and you take the MSR CVD and TR. Okay, yes, so see here, for example order of the fringe is 0. So how to take the order of the fringe is 0? It is nothing but, for example you have to observe these type of fringe pattern in the microscope. So in that, for example you have to start from the dark fringes. So set the crosswire of the microscope like this. So this is nothing but a 0th order or 0th fringe. Okay, then using a knob in the microscope, you have to rotate, so these crosswire of the microscope get moved. Okay, so using this 0th fringe, so this is the first, second, third, fourth and 5th fringe. For example here the 5th fringe is here, so this is the 5th fringe. Using a knob in the microscope, move the crosswire up to 5th dark fringe. For example you have to first consider bright fringe as the dark fringe, 0th fringe, then move to the 4th or 5th bright fringes. But here we have to take the dark fringe as the 0th fringe, so that's why, so this is the first, second, third, fourth, 5th dark fringe. So set the crosswire of the microscope on the 5th dark fringe, order of the fringe is 5. Okay, so like that, using the knob you have to move the crosswire, it is nothing but a order of the fringe. For example, so this is the 0th order of the fringe, you have to take the MSR and CVD value, then you have to using the knob move 5 dark lines, so nothing but it is the 5th order of the fringe, so then you have to take the value MSR CVD. Okay, then again move the 5 dark lines and take the value MSR CVD. So like that, up to you have to measure the MSR CVD for 55 lines. Okay, yes, so every 5 lines, so we have to measure or take the value MSR CVD. Okay, so after that, width of 30 fringes, it is omega. Okay, so what is width of 30 fringes means? So here 9.6 is the TR value for the 30 fringes. So here 9.2 is the TR value for 0th fringe. So here, so 9.655 minus 9.253, it is nothing but a width of 30 fringes, it is 0.402. Okay, so like that, 9.7 minus 9.3, 9.756 minus 9.405. So like that, it is, we get the 6 readings for the width of 30 fringes. So after that, take the mean width of 30 fringes. So it is omega is equal to, so summation of omega dash, so it is omega dash, so omega dash divided by 6. So it is the mean width of the 30 fringes. Then after that, so mean width of a single fringe, so it is beta is equal to omega divided by 30. So we get the mean width of a single fringe. Okay, so after that we get the beta value, so and so calculate the thickness of the paper, T is equal to lambda L divided by 2 beta. So approximately the value of the thickness of the paper, so T is equal to 1.87 into 10 raised to minus 4 meter. So see here, the thickness of the given paper, T is equal to 1.87 into 10 raised to minus 4 meter. So this is all about the interference of a wedge or air wedge. Okay, yes, thank you.